Hello, welcome again to Machine Learning Tips. So today we are going to be looking at base knowledge in probability and sampling, where we are going to see basis of probability and basis of sampling and what and bias. So probability is like the likelihood of an event happening, and that good example of that event here, it could be maybe you roll a die. When you're playing a Ludo or something like that, and then you want to maybe get the number of even heads from that die. So if you want to calculate the probability of such an event, it will be the total number of favorable outcomes, which in that case will be the number of even numbers that you get when you roll that die divided by the total number of what outcomes. So in that case, a die is always made up of six-sided. So in that case, the total number here will be what? 6. So most of the times, the probability of that event, for example, which you are obtaining those even numbers when you roll that die, is always less than or equals to 1, but greater than or equals to what? 0. So if we are certain that that event is never going to happen, meaning that if we are certain that we are not going to obtain even numbers when we roll that die, and then that probability is what? It says that is 0. But if we are certain that that event is going to happen, meaning that we are going to obtain those even numbers, then that probability is going to be what? 1. So some of the key rules in probability are what? The first rule here is what we call complement. Complement here is like, if you want to, in the case of rolling that die, if you calculate the probability of obtaining even numbers and you want to get the probability that you are not going to obtain even numbers, which in that case will be odd numbers, we are going to get that what? In that case, it will be the complement, which will just be what? 1 minus the probability that you are going to obtain those even numbers. So one thing you have to note here is that the complement of the complement and the probability of that event will always be what? The sum will be equals to what? 1. So for example, here we can say maybe the probability that is going to rain is what? 0.7. Then the probability that it won't rain will in that case be what? 1 minus 0.3, which will be what? 0.7. So another rule in the probability is what we call addition. So addition here has to deal with cases where we are looking at the probability of two events occurring. Let's say if those events are mutually exclusive, meaning that there is no relationship between those events, like there is nothing common between them, then that intersection will be what? 0. Let's say in the case of ruling that die, the probability of obtaining even numbers and odd numbers, there will be no intersection between them. So if the event A is obtaining even numbers and event B is obtaining odd numbers, if you look at the intersection between those numbers, it will be 0. So in that case, the probability of obtaining even or odd numbers when you roll that die will simply be what? Equal to the probability of obtaining even numbers plus the probability of obtaining those odd numbers, which in that case, that sum will be what? 1. So another thing here is what we call the multiplication rule, which happens for independent events. Independent events are events that occur separately. Like in the case if we are rolling the die and we say the probability that you are going to obtain even numbers is independent of the probability of that you are going to obtain what? Odd numbers. So in that case, those events are independent and then their intersection will be what? Probability of A multiplied by the probability of what? B. We are going to see this a lot, especially when it comes to the naive Bayes algorithm, which is a classification and supervised learning technique. So some of the intuitions we have been mentioning this a lot, like in the case if you want to toss a fair coin, if you are doing it just once, fair here is that we are tossing a coin which it has equal probability of obtaining a head and what? And a tail. So if we do it just once, then we have the sample space here will be 2, and then the probability of obtaining a head will simply be what? We have just a single head here will be 1 on 2, and same with tail. So the probability of obtaining head and tail here is what? Is same, which is 0.5, 0.5, and you sum this, it will be equals to what? 1. Also ruling a die, the sample space, as I did mention, will be 1, 2, 3, 4, 5, and 6. The probability of obtaining even numbers here will be simply what? The even numbers here are 2, 4, and 6. So it will be 3 out of what? 6, which is what? A half. So let's look at sampling. Sampling is like selecting a subset of data from what? A larger group or population to make inferences. Now, we see sampling is very essential, especially when we are collecting data. Most of the machine learning models that we'll be building, we are going to be sampling data from different things or different places, or also from different applications. So because most of the times we are unable to get the entire population, so we will have to deal mostly with what? Samples. Like for example, if you are doing a census, you want to get maybe the average height of males in a particular country. You might not be able to get all those males in that country. So what you have to do is just what? To just get a sample and then use that sample to make some inference from that population. So that's why here we are looking at the population to be what? An entire group, which in that case could be all students in a class. Also, a sample here will be what? The subset of that population, which will be out of this all students in that class. I just need to carry out a survey on 100 students. Why is sampling very important? It is important because it is easy to get, it is faster, and also cheaper than going to the entire population. Like in the case of obtaining the average height of men in the country, if you want to go to the entire population, you are going to spend a lot of time, and also it will be very expensive to do that kind of survey. So there are different types of sampling. We have what we call random sampling, when every member in that sample that you grab has an equal chance of being selected. Most of the times, we are going to see more of random sampling. It depends also on the study that you are doing. We might have what we call another sampling type, which is stratified sampling, when you divide maybe the population into subgroups and then sample from each of those groups. Maybe in that case, you are trying to do maybe a study on looking at climate from different countries. You might try to group countries that you think that their climate are a little bit same into those subgroups and then pick that sample from there. Another type of sampling we have here is cluster sampling, which is like dividing those groups. Stratified sampling and cluster sampling is a little bit similar, but what you do here is with cluster sampling, you select some clusters. But with stratified sampling, you are going through each of those samples and then grabbing members from that sample. But with cluster sampling, you are just picking, okay, I want just these clusters. I don't want to sample from the entire all the clusters that that these groups of people are into. Another one kind of sampling we will see is what we call a systematic sampling, where you are selecting every key element from that sample. Maybe you go into a population, you say, okay, I only want people with this particular height. So what is bias? I did mention that most of the machine learning models that we are going to be building, we are reducing bias and variance. Now, but when we come to sampling, bias occurs when, you sample data that is not a representative of the population. Now, we have to be very careful if you are building models when you are doing sampling. If you sample data which is not a representation of that population, or maybe the data you're trying to use, maybe building models for spam detection, something like that, those models will be biased towards that sample data that you use. That is why we have different kind of bias. We have selection bias, which is like you are selecting just some groups more likely to be chosen than others. Like in the case of, say, spam detection model, you are using just English data set to train a model to distinguish whether an SMS is spam or non-spam, but you cannot generalize model to use cases like spam text in French, spam text in Italian, spam text in Spanish, and so on, and so on. So another kind of bias is response bias, which is participants give inaccurate answers. Maybe you are saying, okay, this color is blue. Somebody is saying that, oh, the color is not blue, and so something like that. Even what we call survivorship sampling, which is maybe in the case of a war environment, you only sample people that survive and not considering people that died during that war. So sampling bias is very, very common, and in most machine learning models, it is always good to reduce that bias as much as possible before we use that data to train those models. So why do we have to look at this sampling? Why is it very important? Training data for most machine learning models is like just a sample of the reality. So in that case, if that sample is biased, then that model is going to learn that bias, the bias pattern, and in that case, the model will be very biased in making decisions. Let's say an object dictation model, which is used a lot in by law enforcement officers. You use maybe just images from a certain group to train that model. If that model is used by those law enforcement officers, it will be very biased towards certain groups. It might say that this person he committed a crime when that person did not actually commit that crime. Another good example is in case of spam dictation, where you train that spam dictation model on English emails, but in that case, it will fail on what? French spam emails, because that model wasn't trained with what? A French spam emails. So guys, that is why looking into bias and sampling is very, very essential when it comes to machine learning. That was it for today, guys. Keep following me for more tips. You can subscribe to my YouTube channel as well as follow me on YouTube for more of these tips. Thank you so much.